YARP and Ocelot are among the most popular libraries for building API gateways in .NET, and in this video I want to compare them based on ease of use, documentation, load balancing and rate limiting support, authentication and authorization, and most importantly, performance. So by the end of this video, you should be able to make an informed decision for which of these libraries you should use in your application. The main goal of this video is to do a high-level comparison between YARP and Ocelot, highlight the most important and most frequently used features of these two libraries, and then we're going to try to make a decision as to which of these two libraries is the better one. YARP is actually short for yet another reverse proxy, and this is a library that is built and maintained by Microsoft. It's a newer library than Ocelot, and therefore it's not as popular from what I've seen. However, it does have 8.5K stars on GitHub, and this is the GitHub repository for the YARP reverse proxy. Here you can find some high-level information, and also there is a documentation link right here. Ocelot is also pretty popular on GitHub. It has 8.3K stars, so just a bit less than YARP. However, it also exists for much longer. The current version is 23 point something, and this project was in an uncertain state for some time. I recall that it wasn't maintained for a couple of years, but recently the development has picked up again, so I think it's a viable option, and still many people are using it to build an API gateway for their applications. So here you can also find some high-level information as well as documentation links for some relevant topics. Now let's check out the documentation website. This is the documentation for YARP. I've spent quite a bit of time in here, and I can tell you that the documentation is pretty good. You can find most of the important documentation right here, like how to implement direct forwarding, how to implement authentication and authorization, support for WebSockets, gRPC. All of this is handled out of the box with YARP. And the Ocelot documentation is also pretty good. It's a very robust and feature-rich API gateway library, and you can do quite a bit of cool things with it. Now, I'm going to go into the code and show you how to implement simple support for both YARP and Ocelot, and then we're going to extend it with some additional features. So here's what I want to implement. I have a web API called the Products API, and it exposes a set of CRUD endpoints for working with the products resource. This is a RESTful API, it supports HateOS and all of the good stuff, and we have simple get endpoints, post, put, and delete endpoints, and we want to be able to place this API behind an API gateway. So I'm going to show you how to achieve this with YARP and Ocelot that I added as empty .NET applications. I configure everything to run inside of my Docker Compose setup. So when I start my application with Docker Compose, it's going to run the YARP gateway, the Ocelot gateway, and one instance of my products API. We're going to add another one later when I show you how to implement load balancing. But let's close everything down and let's see how to implement an API gateway using YARP. And because YARP and Ocelot are libraries, we have to start by installing the respective NuGet package. For YARP, you want to install the YARP reverse proxy, and the latest version is 2.2. So I'm going to go ahead and install it. And then let's open up the program file where we have to add a couple of things. Or to be more precise, it's two things. The first one is setting up the YARP configuration. So I have to say builder services add reverse proxy, and this will add the relevant services, and then I want to load the YARP configuration. And I can do that by providing a configuration section. So I'll say builder configuration get section, and the default name for this section is reverse proxy, so that's what I'm going to use. And then the second thing is calling app map reverse proxy, and this is going to apply this configuration and map the respective API endpoints. So this is all there is to it from our .NET code, and now we just have to provide the reverse proxy section in the app settings JSON file. So let's go ahead and do that. I'm going to create a reverse proxy section, and we're going to split this in two parts. The first part is routes, and this is going to contain my configuration for the upstream and downstream routes. And the second one is called clusters, and this describes what are the downstream services that we want to proxy our requests to. So let's begin from the clusters, and all you have to do is give a meaningful name to your cluster. I'm going to call this the products cluster, and I want to define a property in here called destinations, and this will be an array of the available destinations. And the first destination is going to contain an address that I'm going to specify as http products API and then the port 8080. This value is actually coming from my Docker Compose setup. So you can see that the name of my container is products API. So this is the internal URI inside of the Docker network that I can use to reference this application. And the HTTP port is 8080 as set as configured by my environment variables. So that's where the value is coming from. So now that I have my cluster, I can go ahead and configure as many routes as I want. And let's call this the products route. The first thing I have to do is to associate this route with a respective cluster by specifying the cluster ID, and the value is going to be the name of my cluster. And then I have to define a match for how I'm going to associate respective incoming requests with this route and then be able to proxy them to my downstream API. So I'm going to specify a match based on the path, and the path is products, and then I can specify a catch-all variable or a wildcard, and this is going to match all incoming requests on the products route and then proxy them to my API running on this address. The catch-all wildcard is going to match anything coming after this route and proxy it without any changes to the downstream API. Now here you can also do a bunch of customizations, add route transformation, like transforming your route paths, adding headers, adding claims, and a bunch of other stuff. Now, I don't consider this too important for our example, so I'm going to leave it out. And this is going to be our base setup for just proxying incoming requests to the downstream service. Now, let's see how we can achieve the same using Ocelot. And I'm going to start by installing the respective NuGet package. So let's look for Ocelot, and I'm going to install the latest version in the Ocelot Gateway project. Let's close this down, and I'm going to open up the program file of this project. And this is going to be somewhat simple. I'm going to say builder services add Ocelot to add the required services, and then I'm going to say await app use Ocelot. So this will set up the required services and include Ocelot in the request pipeline. But when it comes to the configuration, the most common approach is by specifying a custom file by calling add JSON file. I'm going to specify Ocelot JSON as the file that's going to contain my configuration. This won't be an optional file, so I'll specify optional as false, and reload on change should be set to true because I want to pick up any changes made to this file. Now I don't have a file like this yet, so let's go ahead and create one. I'm going to add a new item called Ocelot JSON, and let's actually turn this into a JSON file, and then let's see what we have to configure here. Now the good thing is you're going to have some IntelliSense when it comes to the available options. You can see it's offering me that I should either add a route or a global configuration. I actually want both of these values, where the routes is an array of individual routes, and the global configuration is where I can configure the base URL. And this value is going to be the globally accessible URL where Ocelot will be running. So this is going to be localhost 4000 using HTTP. You could also use HTTPS, and then you should specify HTTPS 4001, but I want to keep it simple. Now, the documentation also states that if you're running this inside of a container, you should still use the publicly available address. So I'm using localhost 4000 here. So now I can go back to my routes configuration, and I want to start configuring my routing. And the first component is going to be my downstream properties. So I want to specify a downstream path template, and this will represent the request that I want to send to my downstream API, which is the products API. So I'm going to use the products route, same as with YARP, and the wildcard in this case is called everything. So everything coming after the products route is going to be sent to the products API. The downstream scheme in this case is going to be HTTP. I can also specify the downstream hosts and ports, and this is also an array if I want to support load balancing. So I'm going to specify the host as products API, and then the HTTP port is going to be 8080. So this is my downstream template referring to the products API. Now, when it comes to the request I'm sending to Ocelot, I need to specify my upstream template. So the upstream path template is going to be products and then everything. So we're matching what we already have in YARP. And then I can also configure the upstream HTTP methods. So this can be get, put, or let's say post, then put, and then delete. So these are the HTTP methods that I want to support with my Ocelot gateway for this upstream template. You can also place the upstream templates first, followed by the downstream templates. It won't affect anything, and I guess this will depend on what you find more intuitive. For me, it makes more sense to first configure the incoming requests, which would be the upstream template, followed by the outgoing requests from my gateway, which would be the downstream template. Now, with this setup in place, I should be able to start my project and test out my two gateways. So now I should be able to send a request to my YARP proxy, which is running on the port 3000, to fetch a specific product, and if I send this request a couple of times, you can see that we are getting back the response. If I open up Docker Desktop, you can see that I have my two gateways running in their respective containers, and if I open up the YARP logs, I can see that it's proxying the requests to the respective address where my product's API is exposed. You can see the downstream address here. Now, if I go back to Postman and send another request, this time through the Ocelot gateway, which is running on port 4000, you can see that I'm getting the same response back. Now, one thing to note here, which you might find interesting, is that the HateOS support inside of my API isn't aware that this is running behind a proxy. So we would have to update this to expose the proxy route instead of the API route for the HateOS links to work as expected. But if I open up the Ocelot logs, you can again see that it's proxying the requests to the respective downstream address, which you can see in this log statement here that's referencing the downstream template of the product's API. So our two gateways are working as expected. They're able to proxy the request to our API instance. So let's just briefly look at the initial setup side by side. So this here is the YARP configuration, and this here is the Ocelot configuration. And you can see that they're more or less very similar. I find both of the approaches pretty intuitive, and it's not too difficult to figure out how to configure all of the required things. Now, let's say I want to introduce load balancing into both of my gateways. When it comes to YARP, we would have to introduce another destination for the cluster, the products API cluster. So I'm going to specify another address, and this is going to match the URL that I'm configuring in my Docker Compose setup. So it's going to be products to API and then the port 8080. Now, when it comes to Ocelot, we just have to expose another pair of host and port. So the host is going to be products to API and the port will be the same, 8080. And then when it comes to the YARP setup, I have to specify the load balancing policy on the cluster level. And there are a bunch of built-in policies. I'm going to use the simplest one, which is round robin. So it's going to send one request to the first address, another request to the second address, and then rotate between them evenly. When it comes to Ocelot, we have to specify the load balancer options property and set the load balancer type to round robin. So you can see it's pretty similar between both of these gateways. So let's start our application and see if load balancing is working as expected. So let's send a request to our YARP gateway, and you can see that the HateOS links contain the URL of the first API. But if I send it again, it now contains the link of our second API. So the load balancing is working as expected. If I keep sending these requests, you will see that we are doing round-robin load balancing between our two API instances. If I head over to the Ocelot request and send it again, first you can see that we get a response back from the products API, and if I send this again, now it's returning the same response from the second products API. And you can see that if I keep sending them, the requests are going to alternate based on the round-robin policy and which API instance is serving the response. So we can conclude that the load balancing works as expected. Now let's try out rate limiting. So I'm going to add a rate limiter inside of my YARP setup, and we actually have this built in ASP.NET Core. So I can call builder services add rate limiter and configure my rate limiting policy. In this example, I'm configuring a fixed window rate limiter, and this is actually a rate limit partition, and the partition key is the individual path. So we're going to rate limit all of the requests incoming to the products path. Now, when it comes to the fixed window rate limiter options, I set the permit limit to 10 requests in a 10-second window. And then to apply this to the YARP setup, we would go to the route and specify the rate limiter policy, and I can just specify the policy name, which is fixed window. If I want to achieve the same with Ocelot, it's not entirely possible. You can do something similar with a setup like this. So you configure the rate limit options, and here you're going to enable rate limiting, set the rate limit period, what is the request limit in that given period, and this is supposed to achieve a similar policy to the one that I set up in the fixed window rate limiter. So in this regard, YARP is much more powerful because it integrates with the built-in rate limiter support, and other than the fixed window limiter, we also have sliding window, token bucket concurrency, and you can easily implement a custom rate limiter algorithm. Also, one thing you have to do with YARP is also include the rate limiter middleware. So I will say app use rate limiter, and then rate limiting should work as expected. So I can start the application now. And if I start spamming my YARP gateway with a bunch of requests, I hopefully will be able to run into the rate limit, and you can see that this happened now. And in case of YARP, or rather the default rate limiter middleware, the response is 503 service unavailable. But when the fixed window expires and I send another request, you will see that we get a response back. Now, when it comes to Ocelot, let's see what's going to happen if I send a bunch of requests in a small enough time window. Hopefully you're going to see the rate limit, and in this case the response is 429 too many requests. And you can also configure this with YARP and the default rate limiter middleware to return a 429 response, which I think is more appropriate when you reach a rate limit. Ocelot also includes a nice error message that you exceeded the available quota for the allowed API requests. But also, when enough time passes, I can send a request again and the rate limit is refreshed, and I will be able to get a response back from Ocelot. So now let's briefly discuss authentication and authorization. With YARP, you can set up an authorization policy, and there are two default values: anonymous, which is the same as setting allow anonymous on a minimal API or controller endpoint, and you're basically allowing unauthenticated requests to this endpoint. You can also set the default authorization policy, which is going to require an authenticated user. Now, you will have to configure authentication as another middleware in your pipeline. So you're going to say builder services add authentication, and you'll probably need to call builder services add authorization, and you'll configure bearer token or cookie authentication, and you will also have to include the respective middleware. Now, where YARP is really awesome is you can also specify a custom authorization policy like this. Let's say I call it custom policy, and then I can say builder services add authorization and add a delegate for the authorization options. And what this allows me to do is call the add policy method. And now I can add a policy called custom policy and use the policy builder to define my custom policy. And this could check if there are some claims present. For example, I can easily implement role-based authorization using this approach. When it comes to Ocelot, the setup is more or less the same. You will need to configure the available authentication mechanisms, and then in your Ocelot settings, you're going to set the authentication options and provide the authentication provider key. And let's say that we are using JSON Web Tokens and the bearer scheme by default. This is how you would enable authentication. When it comes to authorization, Ocelot by default supports claims-based authorization. So it's a bit more limited than YARP is. YARP allows you to customize the authorization policies, whereas Ocelot expects a given claim to be present. So let's say I want to check if a user contains a claim called role with the value of registered. This is how I would configure that. And one more thing I want to discuss is performance. And what I'm going to do is comment out all of these values. Let's also just use one API instance. So I'm going to comment this out. So I don't want to be using load balancing, rate limiting, or any of that stuff. I'm also going to disable authentication and authorization. So we just have a basic reverse proxy setup with both YARP and Ocelot. And just for good measure, I'm going to omit the rate limiter middleware. And what I'm going to do is start the application using Docker Compose, and then we're going to do a performance test using K6. So I'm going to start my Docker Compose setup using Docker Compose app from the CLI instead of going through Visual Studio, because Visual Studio adds some overhead for debugging. I'm also going to set the log levels to warning to minimize the impact of logging on my performance benchmarks. When it comes to the K6 scripts that I'm going to use for running these performance tests, it's going to be very simple. I just want to send one request to fetch a product with a given ID from the YARP proxy, which is on this URL, and the Ocelot gateway, which is on this URL. Both are going to use 20 virtual users, and I'm going to do a ramp up for 10 seconds, followed by 50 seconds of continuously having 20 virtual users. And we're just going to validate that we are getting back a 200 OK response. So if I go ahead and say K6 run and then specify yarp test.js, this is going to start my performance test using this script file and is going to start hitting my YARP gateway. It's configured to just proxy the request to the product's API, and after 1 minute we're going to take a look at the performance test results. And the results are in, and we managed to get about 532,000 API requests, which equals to 8,800 requests per second. I think this is pretty respectable, considering that my machine is also under some additional load right now. Now let's go ahead and run the same test for Ocelot. So I'm going to say K6 run Ocelot test.js, and then let's observe the results after 1 minute. And the results are in, and with Ocelot we got just under 500,000 requests, or almost 8,300 requests per second. So you can see that Ocelot is noticeably slower. Now, in some separate performance tests that I ran on my own, when my system was under no additional load from recording software and stuff like that, YARP was up to 25% more performant than Ocelot, and I measured this just in throughput or requests per second. But one thing I want to highlight when it comes to Ocelot is the amount of features that you get out of the box. Ocelot, being the older project of the two, spent much more time under development, and it also supports service discovery with console out of the box. One feature I find particularly interesting is request aggregation, where you can configure how you want to aggregate a response, or you can configure a so-called aggregate request, where you send one request to the gateway and is going to issue multiple requests to the downstream services, combine the responses from these services, and then return the aggregate response. So in this example here from the docs, we are sending one request here and another request here, and then we can define an aggregate request by specifying the route keys. So you can see these two values here match the two requests, and when we send a request to this address on the gateway, it's going to issue the request to the underlying services and return back the combined response. The response, I believe, contains the name of the paths, the name of the route keys as you configure them here, and then the JSON payload under that route key. So this can be interesting if you are doing aggregation of results from multiple API calls. Ocelot supports this out of the box. With YARP, you would have to implement this yourself somehow. And if you're enjoying this video so far, then go ahead and smash the like button under this video so that the YouTube algorithm knows to recommend it to more .NET developers. By now, you hopefully have some idea of how to compare YARP to Ocelot. I showed you what the configuration looks like, how to set up load balancing, rate limiting, authentication and authorization. We also did a performance test that may have been a bit underwhelming, but I have to note that my system is under some load from the recording software that I'm using to make this video. In my offline testing, I managed to get up to 25% more throughput using YARP when compared to Ocelot. And I think this is a significant performance improvement for just using a different API gateway. And for some folks out there, this could be a significant performance improvement for just switching from Ocelot to YARP. But let me know in the comments what you think about YARP and Ocelot and which of these two libraries you would use in your project. Now, if you're building distributed systems, one thing you will definitely need is distributed tracing. And if you want to see how to set this up from scratch, then you should watch this video next about using OpenTelemetry to implement distributed tracing. I hope you got value out of this video, and until next time, stay awesome.